Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue. Today is episode 187. Before we get started, a quick reminder to follow Identity Office Hours on LinkedIn. We're 27 followers shy of 2,000. The topic today is automated reasoning meets AI, the next leap in verified infrastructure. Our guest today is Varun Pant. He leads engineering and product at the AWS Automated Reasoning Group, and our fractional co-host, Rohit Kare, is here today, an unreasonable advocate. So welcome, guys.
Welcome.
Hey, thanks for having me.
And Varun, because you're a first-time guest, maybe you could tell us a little bit about your background and career trajectory.
Yeah. Thanks again for having me. As you said, I work at Amazon. Before I get into my introduction, obviously all opinions are my own, do not reflect that of my employer. I actually chapter one of my career was actually in mechanical engineering and space robotics. Did a lot of that. Came over to Carnegie Mellon and continued doing that, but then started taking courses in computer science and then did another degree in CS. And since then, have been working in the industry, joined Amazon as an IC, worked in the database space, and now most recently in the automated reasoning group.
So, Rohit, I'm going to go to you for a definition of automated reasoning. What is automated reasoning and why does it matter?
It's good old-fashioned AI, right? In the era before deep learning and neural networks, we were really proud of getting symbolic logic done on computers, algebra, mathematica, the ability to solve word problems, reasoning and first-order logic are the stuff that, traditional computing and algorithms are made out of. We'll talk a little bit later about some of the history of it. But in its modern universe, we rarely see it as developers. Developers will occasionally hear about exotic technologies like TLA plus for modeling and verifying temporal protocols or network protocols to say, what state is the system in? Or they'll hear about Paxos as a way to do consensus and make sure that there's only one computer in charge at a time, and that 51% coalition of servers and Bitcoin is in charge. And so we see these safety guarantees come from time to time, but there's an entire world of languages and math for proving these properties solidly true. And we'll introduce some of these terms and jargon as we go along. But the point is that you're working in the land of proofs and specifications rather than in the land of actually what registers are being loaded and what electrons are shuttling here and what's on the tape. This gap between implementation and proof is one reason for kind of this famous quip, which I'm afraid I'll probably mangle, but I think Knuth was attributed to the great programmer Don Knuth in .77, which is that be careful using this program. I have only proved it correct. I have not proved it works. Because it's possible to prove that something is safe and won't deadlock, but the way you've implemented it is you've loaded some library and it has a memory bounds error and something else is off. So automated reasoning is indeed classic Blackboard logic. It has been incredibly powerful at verifying safety critical systems, aerovionic systems, and in particular, we get here to the branch point for today's episode. A great paper laid out a title of a piece on why Amazon in particular has ended up building quite a group under a professor that they poached, Brian Cork, called The Unreasonable Effectiveness of Automated Reasoning and Cloud Security. And that's where I come in, which is that in a world where you've got probably almost 10, 20,000 permissions in Amazon Cloud and Google Cloud and so on, being able to reason about how do I keep an S3 bucket in my company always is either encrypted if it's public, and that is a simple rule I'd like to enforce. And the fact that we have the ability to prove that's the case is why we're so excited about automated reasoning. It's the latest name for this field, and automated reasoning and security in particular. Led to that again, great paper about the unreasonable effectiveness of automated reasoning and security. It's based on a long intellectual tradition on the unreasonable effectiveness of X and Y. And one reason why I'm an advocate for these kinds of unreasonably effective things. It's just in a market right now when billions or trillions are being spent on statistical methods and LLMs, good old-fashioned AI needs a bit of a comeback.
Yeah, so a lot of times I was at the MCP Dev conference maybe 2 weeks ago, and I must have heard the word guardrails like 15 times or 15 times per talk. So Varun, what are formal guardrails?
Yeah, so just to take a step back, we know that these LLMs are probabilistic; they're not deterministic, and so therefore, a key challenge with them is to ensure the accuracy of the response. And without validation, these LLMs can produce hallucinations or incorrect information, and that really undermines trust. So uh, in December of 2024, and I think it GA'd over the summer in 25, we launched automated reasoning checks in Amazon Bedrock Guardrails, which helps solve this problem by using formal methods and mathematical techniques to validate that the natural language content is, compliant with the policies that you define. Um, so those are one sort of formal guardrails that we've been working on.
Hmm. Um,
Would you like to give a quick example of one?
Yeah. So, let's imagine you had a vendor bender and you go to your insurance provider, and your insurance provider has a bunch of rules which dictate when and how to give you your claim. And so it's effectively, imagine that they modeled that their rules, which were in natural language, we converted that into using the automated reasoning checks into a formal language called SMT lib. And then this subset of SMT lib is then used. And every time you ask a question, so for example, hey, I had a fender bender, am I eligible to get claims? So based on your profile, they would go and check your ask against those rules, against this input, which would be formalized into this formal semantic, and then the answer that you'd get would be deterministic, as opposed to other techniques like LLM as a judge, where you put another LLM with some prompt engineering and ask it to follow some rules, but it can't because that's how it's designed.
If I may,
yeah,
point in the reading to one of the examples that you give in Amazon's blog, and it says like claims must be filed within 30 days. And you don't want it to be some arguing about, well, 31 days in this month, or talking with someone in English. There to actually translate into a satisfaction query that can be checked for exactly how many days it's been.
um,
Sorry,
yeah,
Mike, to throw you off with that clarification. I think we're back at, why, what are the guardrails and where are they useful? That also
yeah,
speaks, why these guardrails are an interesting contrast point. Formal guardrails we're used to is like, look, if you don't have sudo access, you are absolutely not going to be on, if you're not on the sudoers list, you can't take super user and delete these files, right? That's a classic hard mandatory access control type isolation boundary we'd like to have in our computer systems. And sometimes you make a spec very rigid, 30 days on a policy, as the example that was made there, an insurance claim that's after 30 days late is not going to get paid. Well, now you have the question of escalation and exceptions. I think a couple of days ago we had uh, Dick Hart on talking about AOTH and kind of maybe there's a place where sometimes you need judgment. But there are some places where it's appropriate to have a human customer service thing and have a record of the exception and kind of a dialogue about what's reasonable and not reasonable. There's other places where it's point blank, like, make sure that there's not a loophole in the system that allows people to get paid out in a different currency than they paid in. That's the kind of thing you want to be able to check and put a formal guardrail in.
yeah. I remember I lost my train of thought there for a second, but I wanted to push more on the why LLMs can't verify the output of LLMs. You mentioned that a couple of times, Varun. But I want to push on that a little bit because Rohit, you mentioned Dick Hart, who was a guest on last Thursday's episode, and he expresses the mission of the agent in Markdown. And I asked about verifying that, and his answer was that, well, the LLM will be able to do that. So it sounds like there's some skepticism as to whether that's true. And Varun, I was wondering if you could maybe give us some more detail on why that might not be the best approach of having the LLM guard or verify the policy.
Yeah, I think there are two top reasons that come to mind. There may be more. The first is in how these models are trained, right? They're stochastic, and so by nature they're looking at patterns and they're generalizing. So they're great for creativity and generalizations, but um, at a point where you really care about correctness, they're not the only tool, and I think they have to be coupled. And so there is this term, and I'm going on a tangent, called neurosymbolic, which has been used, which is a hybrid approach that combines these neural networks with symbolic reasoning from automated reasoning. And so I think that's where I think we're headed. And the second reason is that a lot of times for these LLMs and agents, they forget the instructions for like multi-turn interactions. Like maybe until the sixth interaction, or right, or the conversation, whatever it may be, they will remember your MD file. But maybe on the 50th, they may forget that, hey, you're actually supposed to check a certain criteria when you're giving the claims out. And the difference between that could cost you, because again, depends on the business use case. But if you had the fender bender example, you could give incorrect claims out.
If I may add to that one, the idea that LLMs are unreasonably effective, like there's another version of the long heritage of these academic papers called Unreasonable Effectiveness of X. One of the most famous in our world of AI right now is the bitter lesson. The bitter lesson is the unreasonable effectiveness of data and machine learning. That you could either make a machine learn how to do chess and beat Gary Kasparov with Deep Blue and IBM in the 90s, or you just keep building general purpose deep learning systems, and now without any prompts at all, you can get a system that will beat all human grandmasters in chess. And the bitter lesson is that more data might do better. And so if I take a little bit of caricature and liberty to what Dick and Person Server might be saying in AOF, in the future, do we just add a prompt like ultra think, telling Claude to think hard? And I might say, don't embarrass me and don't lose my money. And just by adding those magic words, it'll become secure. And that's the possible counterexample, was that LLMs will magically do it. But I will say neurosymbolic is much more likely the future. We're hitting scaling walls in LLMs. And Claude Code and its ilk are the ultimate current example of a neurosymbolic system. The ease of chat and talking to humans and modeling the world, but the world of writing compiled formal code, and whether it's Python or, as we'll talk about in a second, languages like Cedar or policy languages, or using proof tools like Lean. The world when you put the AI to work, where the LLM plain English gets into a language with formal semantics, has proven to be the current superpowered mix where AI has raced ahead and had the most economic impact. I'm hoping the same happens here.
I wanted to reference the homework,
Mm-hmm.
because the article said, like, maybe the answer is we give the problem to the LLM and let it creatively come up with an answer, and then also tell the LLM that you need to provide a proof that it's actually correct. And might that approach work, or is it still expected to fall short? Varun, maybe you have an idea?
Yeah, I think we are actually seeing a lot of research papers and model research papers talking about this. So, for example, I'll talk about math for a second. So we're seeing that Lean's application in solving some math theorems and open conjectures it's highly effective, because what's happening is that these models, which are right, assume that they are trained on the syntax of Lean and they are getting better at it. They are able to informalize patterns, right? So they're able to draft up the plan, and then tools like Lean, we can talk about it in the next segment, but they have these features which allow the models to interact with them, because it's an interactive theorem prover, and really drive completion of a proof for a given goal or for a given theorem. And as the models get better, I think the informalization ability of these models will get better, and coupled with these deterministic oracles like Lean, I think we'll see a loop where we'll keep seeing harder problems being solved, and we'll also keep seeing the models getting better at it. So, I talked about math as an example, but we have plenty of other examples where we have used this technique, not using perhaps the LLM model, because, for example, Cedar's been around for a while, and we formally verified the model of Cedar and Lean. And so we'll see more of these things come about in the future.
We've been just playing the interrupting here for the as navigator, like the audience, and being play acting the listeners here. We may have introduced some terms along the way that deserve a little bit more explanation or glossary. the interactive theorem prover idea is a bit like an IDE is for writing code. And the experience that helping the LLM helps guide you write the proof along the way. And it'll help you find the inconsistencies, or it says, I need a tactic or a strategy here. So he said, interns shouldn't look at production traveler data. It might say, hey, could you help define the axiom? What's an intern? And then you go over and define that concept over here, saying, go look over here. That's what defines, in the directory service. This ability to say, just like you use an IDE to write code, we're now seeing some very impressive results in productivity of the kinds of folks who used to write proofs, be able to write, 10, 100x more productive. I know there's a little lesser known things, but those are things we can come back to. So the proof runs in parallel with the code, but the idea of having the LLM generate both is great as long as they are machine checked. Mike, that was coming back to your question. You can't just ask the LLM to say, both write me the code, vibe code this thing, and also vibe prove it. It needs to be proven, with math. And that's where there's a little bit more of a complicated process, because LLMs and chain of thought reasoning and so on, all these things we're used to out of our chatbots, remember, they're all optimized for one thing, which is bullshitting a human into believing they did reasoning, right? It'll say, oh, I looked up the credit scores and I gave this person a loan and not that person a loan, and I was very careful not to be racist about it. It's just telling you text that says I was not racist. It doesn't say about what it was actually thinking or doing in an underwriting model, right? That's another place where formal verification of financial algorithms and so on makes a difference.
Rohit, can you just quickly, we've mentioned lean a couple of times, so maybe you could just quickly give us a definition of what is
I'm
lean.
I'm the fat man. I'm pointing at the lean guy.
Okay, Varun, what is lean and why is it having a moment?
Yeah, so lean is actually it's two things at once. It's a functional programming language like Haskell or OCaml, and it's also an interactive theorem prover, which I pointed to earlier. And that makes it a bit special. But to go a bit back, it was created by Leo DeMora, who's at Amazon, about in 2013, back when he was in MSR, I think. And most recently, I think there was a rewrite. So Lean now is Lean 4, which has been around since 2021, operated by the Lean Fro, which is a separate organization, and is completely open source. So to your question, why is it having a moment now? So going back to what I was mentioning earlier with math, I think we've been seeing an inflection point there where there has been this library called MATLib, and effectively it has about, if I'm not wrong, 200,000, more than 200,000 theorems. And so it's like a coherent corpus, and it's community driven. So mathematicians have gone and added base theorems. And the way to think about this is these are like the gravel and sand, so to speak, right? So they're building this library of theorems, and they're using Lean 4 to go prove it. And it's sort of compounds over time that you have certain theorems that are proved, and then you can use those theorems to build new theorems and so on and so forth. And it's a flywheel, right? So if I were to give an analogy with chess, the way to think about it is, in chess, you have you have a goal and you have different tactics that you can achieve that goal with, which is, say you want to, move the knight, or have a sequence of moves, and your goal really is to checkmate, right? And so think of Lean in the same way, where your board position is like the proof state, what you're trying to prove. So you have the goal and the context, and the moves that you can make are what we call these tactics in Lean. And the goal is really checkmate, as I said. And the gravel and sand, which is the MATLib and these libraries of the world, which are the known moves. And so you can sort of build on top of that, right? And the why now moment is also the sort of chess strategy here, which is, what's your approach, right? You can try different approaches. So I could go have a set of move on the knights, or I could have a set of move on something else. And that's where LLMs are really useful, because they're actually able to go build this tree, like a Monte Carlo search tree, and then go traverse that and figure out how it can best go achieve the objective, which is in this case checkmate, or prove the goal. And this was also seen in AlphaZero, actually, that Google DeepMind had, where they actually did use Monte Carlo tree search. And We are seeing that in lean today as well. Another thing with lean is, so I spoke of the tactic framework, which is sort of the finder, but you also have the checker. So, and the good thing about the lean kernel, the lean checker, is that it's only a few hundred lines of code, if I'm not wrong, and its only job is to check the fully constructed proof term, right? So you hand it a proof, it says yes or no, and it's again written, lean files into C, but they also have this concept of metaprogramming. But I'll stop there. That's the high level of what lean is.
To remind just of the basic premise of a lot of these computing languages, chess is the perfectly fine embedding for this problem. Checking is a matter of saying, in this board, is someone checkmated? And checking is, in this move, is that one of the 5 or 10 legal moves you can make? And that's it. It's very short, very sweet to say, I can check a position, say this is a valid solution or this is a valid game. Coming up with a good move, that's the much harder search there, and having tactics or Sicilian openings or so on as the equivalent. But he also asked a very wise question, Mike, about why now. One of America's greatest living mathematicians, Terence Tao, is one of the celebrity names at UCLA, and this new $5 million grant. I'll include the link here from DARPA a few weeks ago. And they say their open source AI platform was able to translate seamlessly between natural language and formal proof systems, while maintaining precision. And he would put it, to paraphrase some of his interviews, as saying the real breakthrough is that Lean has made possible collaboration, that rather than mathematics becoming a loner type of image of someone going off in the corner and being a genius, like Andrew Wiles cracking Fermat's last theorem, now it's becoming a team sport. And so LLMs not only take stuff that's been true for many years, like getting the increasing amount of Moore's law power to make these proof checkers work and proof strategies work and so on, but through LLMs and through this very complicated collaborative product like a MathLib or a CSLib, you're creating a community of people who can build on each other's work very rapidly. It's kind of like watching the revolution of open source and GitHub, hit a field in kind of in the space of just a year and 2 years, not over a space of open source computing. I've been taking like 20. So it's very exciting times.
Yeah, that's interesting. I was thinking actually of what's the kernel module that's made it possible
eBPF.
to. Yeah, it sounds a little bit like eBPF. We've cracked the kernel code in a way, and now we can start building kernel modules faster.
Well, again, in some ways, it's based on secure reasoning, right? We couldn't really secure all of Linux, but there's a language we have for a very short amount of pseudocode inside the kernel that the Berkeley packet filter made possible, and hence eBPF. And proving that it's correct is ultra important, because once it's running, it takes over everything else. So it's been that's a great example, again, where small progress in highly formally verified core kernel thing can unleash dozens of startups and whole new architectures and new ideas.
Yeah, let me share this one. So in the homework, and just a quick note, I'll put up the link. Every episode has a wiki page, a GitHub wiki page, and it's always glue.co/IOH- the episode number. So this will be IOH-187. And we have a link to a talk, a bunch of slides, like 100 slides. I think this is slide number 54 or something. But it shows, so this approach, formal reasoning approach, has been more successful in some areas than others. Hardware verification, cryptographic algorithms, programming languages. We mentioned Cedar. That's where I first ran into Lean and this whole idea of what's an SMT solver and formal reasoning. So maybe let's just start with Varun, like the types, like the successes, like what is Lean good at? Let me get rid of this. Stop
Yeah,
sharing.
so before I get there, actually, Rohit mentioned CSLib, so maybe I should just give a quick 5-second blurb on it. But yeah, so CSLib is another, so just like MathLib is another open source initiative in building this library of for computer science. And the more short-term goal is to have the undergraduate algorithms and theory of computation curriculum formalized into this into this library. And what that allows us to do, I think, in the future is have verified libraries and by default, right? Like so that you can sort of again build on top of that and compound software practices on it. Coming to your question on where have we seen lean in for formal verification. There's a ton of open source projects. I know there's a thing with verifying the Signal messaging app, but I know you have spoken also about Cedar. So that is one example where the model of Cedar has been verified in Lean, and then we've used differential testing to test that Rust code that Cedar runs against that Lean model. There have been other examples too. If someone is interested, there are papers that I can provide links to. For example, with DeepSeek, we saw that model reasoning actually improved by training on Lean. And that was because it was able to reason much better, coherently, had characteristics with transfer learning. Yeah.
Right. Any thoughts on where this approach has been successful?
I think that ironically, crypto and the Web3 bubble brought a few of these things back to mind. It did lead to a certain amount of investment in the area, in addition to what has been going on with computer security. I found it ironic, that the slide deck that you showed there briefly, and I do recommend some interested readers to have a look at it. It's called 50 Years of Formal World, right? That in the early history of computer science, where did logic become? When did it kind of split off? When did it become more of a fad? And kind of talks about AI winter. And it talks about places where formal methods do well. So I was like literally born in formal world. I think New York is one of those places, where I went to school and see it come back is pretty exciting. But crypto actually ended up funding us an interesting wave of startups as well, too, a few years back. And validating these smart contracts, pay off only when they should, or that we don't have these giant scams where, people have been able to rug pull or take money out of these Bitcoin exchanges or other currencies, not like Bitcoin, has been huge. And what's funny is, I was recently talking to an investor, who's a pretty big name in this security investing space. And I said, yeah, I'm really excited about automated reasoning and security. But, I haven't met a lot of other people who are doing this sort of thing. And he's like, yeah, that's what you mean by automated reasoning, formal verification. Yeah, I heard someone doing a smart contract startup. I remember hiring some guy to, come in or asking someone for due diligence, and ended up naming someone else in our same circuit here, right? And that's just realizing, okay, there's not enough people doing this. That's the one reason I'm excited is the technology is up there. The reason I'm a little worried is that we're not seeing enough money becoming this stuff, enough people joining the field, enough awareness of it. So that's why I kind of put myself as an advocate for saying we need to have more investment in this space. If you keep reaching into the same urn and the same couple of advocates come up by name, it's not a great situation, right? I'd like to see more people in the space.
That's a really interesting use for the technology, because I heard this one quip about smart contracts being more like dumb contracts because it's software you can't update, and that's pretty dumb in software. We always want to push updates and fix things, but literally this is a contract written in the blockchain that can't be changed, or code that can't be changed. So I could see if the code can't be changed, then you absolutely need to verify it to make sure that it works in
I don't know.
some other way.
One of the most depressing results in automated software engineering and software repository mining is that if you ask the magic 8-ball, hey, is this change request to the GitHub PR going to be buggy? And the answer was always yes. Because it's like the most recently changed code always has the bugs. Every CL eventually has a bug found in it. And it was realizing, that making software that changes is the one way to guarantee it has new and risky security and safety bugs.
True. The flip
Yeah.
side, I guess, right?
Yeah. But anyway, where
So
it's high stakes is a real issue. Like when you bake things into contracts, again, you don't want to have a LLM open claw prompted, I'm just typing agents to go trade my stock portfolio, right? I actually need to know if I can prove what's the value at risk. Look at disciplines like Wall Street, where there's obviously a much deeper discipline around chief risk officers. Governance is much clear cut. There are mathematical rules about how much exposure you can take. We don't necessarily have those in a lot of other domains of, how much inventory should I keep on hand? Well, that's a little harder to say. But risk management and formal modeling, and rather than doing like vibe trading of stocks, if you want to actually do, again, at the core of these high frequency trading algorithms or so on, they're just as important, even if they're not blockchain use cases. That's another place where you'll find a couple of pockets of these kinds of experts is on Wall Street. But I wish we also had them in like things like medical care, right? So again, how do we build this talent pool of people who are familiar with these technologies and using it in other mission critical software?
right. And you mentioned the example in healthcare, for example, never give somebody too much radiation is really important. Um,
When we went out for Therac 25, one of the foundational lessons in software engineering was, there was a bad interlock and it led to lethal doses of radiation. And it reminds you that you don't blame humans for that. You go back and you look at the algorithms and you look at the device and you say it shouldn't have been certified the way it was. It's still one of the canonical cases we teach, our grad students and software engineering students. What's important, though, is that in the world of algorithms, we don't use humans as we do with AI as these, quote, moral crumple zones, right? Therac 25 killed people. It was an algorithm's fault. It was putting from the market. No one sat back and said, hey, it's the guy who pressed the button. It's their fault. They should have been human in the loop. They ran that accelerator in YOLO mode, so let's just not deal with it. And I'm like, no. It's even kind of somewhat offensive that we even have command line flags like YOLO mode. I mean, software kills people. And literally you only live once, not just have fun with the classifier and hope that Claude code auto classifies what it thinks is safe. Prove it. The classic Reagan translated Russian proverb was, trust but verify. Right. I think we need to move towards a world, especially with GovOps, of verify, don't trust. I think it's a meme that's out there.
Right. So let me go the other direction now, Varun. What we talked about some of the areas where formal reasoning is good. What are some of the limitations of formal reasoning?
Yeah, I think again, one of the key challenges that I personally feel, when I write code, is to make sure that the specification is correct, right? Because I can have a specification and I can have something follow that specification, but the key is to make sure first that the spec is correct, and then you can make sure that whatever the implementation of that specification is, that is correct. So I think it's really important to also focus on some of these upstream things, because I see formal verification downstream of what you define on what your intent is. And so as long as the intent is correct and the user defines that correctly, what do I mean by that? For example, in the English language, there's a ton of ambiguity, right? And so how do you make sure that you get that right? Like, you have to do it iteratively, right? Like, you can't just assume. And so I think, going back to my point on the specification being right, that is key. And you can see that across multiple domains. It's not just policies. It's also for code. It will continue being for wherever you define what you want the AI to do. So I think that's one key thing. The other is, in software engineering, there are other problems that also need to be solved. For example, performance, latency, scalability, and these need prototyping, they need simulation, and I do think formal methods has a big role to play, but so do other best practices that we have compounded over the last 10, 15 years. So that's where I think software engineering holistically will go.
If you bear with me, I have a riff in mind here about your question about what are the limitations on formal methods and where they work in real life. And we try an analogy based on the classic Ray and Charles Ames Powers of 10 video. You're staring from above at a couple on a picnic blanket in Chicago, and you zoom in and you keep zooming in at a power of 10 to the point where you're looking at subatomic particles, and all the way out to the point where you're looking at the universe itself. You might look at a company paying an accounts receivable thing, right? So it's an SSL transaction. It's got a credit card number. It's got someone to pay. And you might ask as you zoom in, hey, are we sure that the chip runs the instruction set we did? And yeah, there's formal verification of chips. Are we sure that it's running the encryption algorithms in SSL the way we think it should? Yep, there's formally verified cryptography libraries. Are we sure that the keys aren't being tampered with between memory and disk and somewhere along the way? And there's these hardware secure enclaves or trust execution environments. And again, things are really high stakes. Those things get proven. Are we sure that the protocol between the browser and the button that says, pay is valid? And we're getting better there, right? Browsers still crash and so on, but the SSL protocols itself have been codified with protocol modelers like TLA Plus or, VPNs like Wireshark. But you keep going up a level and you get to governance and you say, by the way, is the person in the pay button paying an account that's their own beneficiary? It's basically embezzlement, segregation of duties. Now that's something we haven't done, right? That you have to realize that it's a lattice of things all the way down. But as you zoom out towards the messier world of people and intentions, did you trick an LLM into paying a fake expense report and then paying your brother-in-law is going to pay you back? boy, that's a loop. I can write a graph problem for it, and maybe you could do formally verified governance. And right now that sounds crazy, but the vision for GovOps and so on is we keep moving up the stack, and if we can keep as easy to use as plain English, but as robust and rugged as formally verified, that's the grail that we should be looking at for right these days. I think that we can keep moving up the stack and make it work in more places than it works today. End of rant. Sorry.
Okay, so now I'm going to try and bring this back to the actual title,
Mm-hmm.
because the title has AI in it.
Mm-hmm.
And so my question was, what's the intersection of formal reasoning and agentic AI? Because that's the thing that everyone's wondering is can this technology be used for as guardrails for AI? Varun, you want to take a stab?
Yeah. But before I talk about, agent guardrails, I do want to maybe answer the why now bit as well. And one thing I haven't spoken of is something also key here, which is solvers. And again, will not go into the theory, but on a very high level, lean is based on dependent type theory, the Curry-Howard correspondence, if anyone is interested. And solvers, which have been around for a while, they're based on first order logic. And so a couple of things have happened since, say, the 2000s, right? I think solvers, SMT solvers, SAT solvers, they've gotten really fast. There have been a bunch of optimizations that have been made. The second is we spoke about lean. So these interactive theorem provers, they have come along. Specifically lean, we've had a few from before, like Daphne. Um, and then some of these libraries have reached critical mass. We spoke of MATLAB and enter LLMs, which have been really good at what we call auto formalization. We spoke about proof finding at the chessboard, and finally RLVR, which is reinforcement learning with verifiable rewards. We have seen through these papers for DeepSeek, etc., where these models have been trained using these proofs as a training signal, and they keep getting better at that. So these 5 things have really amounted to the why now, in my personal opinion. Going to agents, I think I personally am not I'm not of the opinion that agent safety in a box is meaning where the agent is running is where we are today. I think there has to be a deterministic layer of control outside the agent. And so while you may have your classifiers built in and PII detectors, I think there is that layer that's needed. And there's this refund example, like, hey, I want to make sure that the refund can only be for the original purchase price or less, like, right, and only one refund issued per order. And so you can reason about it with this control layer. And one of the products that does this or has been looking to do this is the natural language to Cedar in Agent Core policy, where you are effectively having this safety control around the agents. But I'm sure that this is sort of where we'll see things headed because of deterministic controls needed. Yeah, curious to hear what others think, though.
Yeah, Rohit.
Well, I think that's the
intersection of agents and formal reasoning.
Well, I think you can say "physician, heal thyself," but we also have the ancient proverb: "Watch who will watch the watchman." Quis ipsos custodes custodes. Of course, the next line is, who will guard the guards? Your wife knows and arranges accordingly, right? That the insider threat and so on, right? And what this means here is that we do need an external set of deterministic logic, because while an LLM can reason about itself, and LLM as judge has a lot of appeal, and it really improves quality, and we're seeing these amazing swarms of agents and coding results and so on. When it comes to kind of high consequence side effect things, money moving, people being reassigned things, jobs being given out, you need to step back and say, This can't be done internally to itself. There's a leaderboard called LL Mail Inject, I think partially sponsored by Azure and partially out of research at ETH Zurich. And it's about whether an LLM that's guarding your inbox can really prevent leakage of secrets like customer data or sales forecasts or so on. And for the couple of years we're running this competition, it's fallen every year. No one's come up with a guardrail because in one general category of things is that, hey, I have an LLM that will look at the prompts you're about to inject and decide to see if it's a malicious prompt. And you end up finding ways to hide it so that that judge doesn't get it. And so now you might say, well, I'm going to have another LLM that's going to look at that. And it's kind of LLMs all the way down, kind of like the bottom turtle, right? There is no bottom turtle. LLMs as non-deterministic language processing games are not in a position to really prove that there's not either a prompt injection attack or a data exfiltration on the return as a guardrail. And when it really chips her down and it really matters, we have to go outside the system to put a deterministic result around it in a real guardrail. And that should be written in a language that is provable. And that's what neurosymbolic systems do. So we've done a lot with the neuro. I'm excited about the symbolic.
So I guess another related question, and Varun, you sort of talked about why now, and you mentioned those 5 factors, but I wanted to maybe dig a little bit deeper on that with a little more skepticism, because this approach has been around for 50 years. And so if it's failed for 50 years or failed to get traction for 50 years, do we really think 2026 is the year where this is going to make a comeback? And I guess really driven by AI, because that's the cataclysmic shift that's happening right now. That must be the forcing function. So I guess I'm just going to skeptically ask you again. I know the technical reasons why you think now, but is now really the time when we think that this can come make a comeback or an appearance even?
Yeah, my personal belief is that yes, this formal methods will go mainstream, but you said 2026, so I'm not good at predictions based on past data points, so I will not predict when exactly that would be. But based on some of these technical data points that I painted, I believe that this technology has a role to play and AI safety is crucial, and that we will continue to see more applications of this. Now, when does that happen? Is that in the next 30 days? And is that in the next year? I think that remains to be seen. The industry is moving really fast, so any predictions are just not as good anymore. But I am a believer, and I do think we have data points from past applications of formal methods. I know Rohit talked about DeFi contracts in crypto, but there are other industries where this has been applied, railways, aerospace, regulated industries, people where mission safety criticality is important. So as we sort of have more applications that come about, hopefully, these things compound and make it go mainstream.
And I'll say, as far as bottom line brass tacks, follow the money, right? We are in a moment where another part of 2026 he's talking about is the supply side, which is that we have new ideas and new technology and new algorithms and new interest in neurosymbolic systems. It's also the demand side. Now, we're seeing AI really upend the economics of cyber defense and cyber offense. Finding new 0-day bugs at scale by just throwing money at an LLM that goes and searches blindly for weaknesses in systems and in old code and memory overflow bugs and all the rest of it might herald a permanent shift towards offense. And that means that, of course, the pendulum has to swing the other direction of saying, well, what's a fundamentally safer baseline for running more secure code and more secure agents? We've seen people saying, hey, let's rewrite a lot of code that's old legacy code in Rust, because at least Rust can give us some commonplace of memory safety. In a world where we're seeing increasingly dire headlines about AI upsetting the balance in cybersecurity, one of the kind of bedrock defenses is to say we actually know what this code is and what it does, and it's not a non-deterministic system. And that's why we can build more secure things on top of this solid foundation. So keep an eye out. It's both the reasons that we're optimistic about how good the new stuff is, but we also are in a moment where the economics of cybersecurity and attack and defense is getting upended, and that's going to also be a reason to be excited.
So the pigeons are flying. We're a tad bit over. So Varun, we have a tradition of doing last thoughts just to make sure that if there's any action items or events coming up, or further reading, whatever you want to share with the audience.
Yeah, I think for the curious, I would encourage you to play with Lean. I think, as Rohit was also mentioning, you can integrate it with your IDE. You can go to the playground. You can start uh, having Claude Code. Play with it. I'm sure people will be able to get some value out of it. And then some of the products that I mentioned, which is automated reasoning checks in Bedrock, and then the policy in Bedrock Agent Core. Those are some products that we've launched, which I would also encourage folks to go look at. And finally, if you're interested in this space, AWS does publish content and blogs about it. And hopefully you folks can also invite more guests who are working in this area.
Awesome. Rohit, do you have last thoughts today?
Yeah, I mean, I could be knocked over with a feather. Earlier this year, Cade Betts wrote a piece in the New York Times about AI writes buggy code. A Silicon Valley startup is out to fix that. And he outlined, a couple of $1 billion in aggregate value in some new startups that are using formalized methods and math here, right? To see the words lean, a theorem prover, in print in a newspaper and in a major mainstream American newspaper is a pleasant shock for someone who's had this in the background. So I think that the level of interest and the level of capital and the level of involvement here says that there's both a real need and a real opportunity. So, I think they will be able to find more about not just the unreasonable effectiveness of automated reasoning in computer security, but I think we're going to start seeing more about the unreasonable effectiveness of automated reasoning in a number of domains and addressing a lot of fundamental issues in AI infrastructure in this year and the coming years. Anything we do to make that Greek to me translated back to something that business people and operators can write. That's part of my hopes too for my last word here on governance is that, some of what we're trying to write as invariants and in the language of math are actually good policies and good governance. And so GovOps, I think, will also be a driver for this innovation.
And maybe we'll have to do a follow-up episode on the intersection of formal reasoning and governance. That's formal reasoning and GovOps.
Mm-hmm.
But let me just say, Varun and Rohit, that was really awesome. Thank you so much for coming on. It was great to see you. And we'll see you at the start of the IAW AIW marathon next week. I know I'll see you, Rohit, maybe Varun this time or some future IAW. They're twice a year. So thanks a lot, guys, for coming on. I just want to quickly, before we go, another reminder, please follow IOH on LinkedIn and YouTube. IOH is sponsored by Glue. The next episode is Linux Security, Face Issues Before Attackers with Peter Cummings. So with that, I will say thank you, audience. Thank you, Rohit and Varun, and we'll see you next time.
Yeah, thanks for having me.
Thank you.